Viewers, let us see the summarization of controllers what we have seen in the past 2 or 3 videos. Okay, so as we have already seen, a controller compares the reference signal with the actual output and reduces the error by generating a control action. For that we have seen an example. See, this is the inverter. So this is Hall sensor. The speed is uh, uh, sensed through this Hall sensor, and which is given to the controller. So the controller creates the control output, and based on this the three-phase inverter switching devices are switched according to produce the required voltage for the BLDC motor to reduce the error to minimum value. And the next one is P controller. So we can compare both all of this PPI and PID controller response within this single graph. You can see, so the red color is the P controller and the green is PI and blue is PID control. How the speed gets varied and settled at the reference speed with respect to the time. So if we consider the P controller, it leaves some steady state error. We can see here, this is our reference speed, but the motor didn't attain its rated speed here. There is some small difference. So you can now clearly see. So that whereas PID controller, it gets some time to reach, but its overshoot is very less. Whereas PI controller responds very quickly, but it produces a high overshoot. So PID controller is preferred for an effective system which gives the smooth control. Okay. So the next one, if you see, let me. Okay, yeah. So if you see, this is the control loop diagram for closed loop control of BLDC motor. So this is the speed reference that we are giving. So PI, this is made up with PI control. So PI speed controller is there, and PWM generator is nothing but a small circuit system which is used to provide pulses for the switching devices in the three-phase inverter, so that the switches will accordingly changes the output voltage at its converter output. That voltage is given to the motor to control the speed. So all this happens with the sensed feedback from the speed sensors or Hall sensors. Okay, so this is how the closed loop system is working. So the effect of controller gains is clearly given here. If you see the Kp value, increasing in Kp provides faster response, but oscillation is too high. See, very high oscillation for very high Kp value. So for medium Kp value, green, it is getting overshoot slightly, but have some oscillation. But when compared to high Kp, it is somewhat lesser. Whereas for low Kp, it is slowly getting settled down to the speed, but it's very slow response, slow response when compared to the high Kp value. So increasing in Ki in the PI controller eliminates steady state error, but overshoot is very high. So increasing in Kd, which provides reduced overshoot, but too sensitive for noise, as we have seen already. Okay. So for BLDC motor, you can use PI controller or either PID controller. So anti-wind up controller also available. We will see that in the next video. And the summary table is given here. You can make use of it. Okay. So this is what about our controller summarization. We will see in the next video with the anti-wind up controller. Thank you.